want to start things off by doing something that is fairly simple, and if what I'm about to explain is ever proven to be correct, it would actually happen billions of times every day. Quite simply, I'm going to take this coin and use it to create a new universe. All I would have to do is flip the coin, not drop it, and then shake it up a little bit, just for good measure. Now, this coin is currently both heads and tails. More on that later. But essentially, I flipped the coin, found that I got a head, and that means that I just created a new universe in which I flipped tails. So I want to explain to you guys just how this works, essentially what the multiverse is, any proof that exists for this, and why it actually matters anyways. Starting off with the quantum multiverse. This is one of the two theories I'm going to be explaining today. And we start off with the double slit experiment. Essentially, if you shoot a wave through two slits, as seen here, it creates what's called an interference pattern. You get it's like two ripples of water running into each other. Now then, if you shoot particles or mass through a double slit, you get two bars where that mass hits the back wall. Picture throwing ping pong balls through two slits. It can only go through where that mass is. Now, the two things that change results in quantum physics are small sizes and observation. So when you shoot an electron through the two slits, the expectation is that much like the ping pong balls, it should create two lines. But it doesn't. Instead, it actually creates a wave pattern, much like if you shot light through it. So what that means is essentially that the wave is interfering with, or that the electron, is interfering with itself. It creates its own wave. It essentially goes through each slit at each time and bounces off of itself and then creates that interference pattern. Now then, if you go back to observation, as I mentioned earlier, if you look at that and you say, okay, I'm going to put a measuring device on here and say, which one is it going through? As I mentioned earlier, observation changes results in quantum physics. Essentially, it then goes back to being the two bars, which shouldn't happen. So the explanation for this is quantum superposition, greatly demonstrated by Erwin Schrödinger in 1932 by his thought experiment of the cat. Essentially, if you have a box, and within that box you'll have a cat, a radioactive substance, a Geiger counter here to measure radioactivity, a hammer, and cyanide acid. Essentially, if you are outside of the box and you are not observing the cat is dead and alive. Because you don't know what the radioactive substance is. So essentially, at any given point, it could decay, open the flask of cyanide acid, and kill the cat. So basically, if you are outside, you are much like the first the first double slit experiment, because you are not observing it to change its results. Now, in terms of the multiverse, this is a splitting moment when you observe something. When I flipped the coin and said that I had gotten the heads, I was this red arrow right here. I was the recording device in the double slit experiment. I created a new universe as a branching point. So now we exist here, in which I flipped heads, and elsewhere in the multiverse exists a universe in which I flipped tails. Now, this is just one of the two things I plan to talk about today, which then brings us to inflationary cosmology. Essentially, the main thing that you need to know here is that gravity can act repulsively. Essentially, in Isaac Newton's mind, gravity can only act to push things together. But given Einstein's theory of relativity, a certain state, referred to as a false vacuum state, can actually push things apart. So basically, now then, this false vacuum state has a rate of decay, so it's similar to a radioactive substance. So say, for the sake of example, that you have a 2 by 2 foot space of a false vacuum. Now then, say its half-life is 1 second. So in that 1 second, a 1 foot by 1 foot area of that is going to decay into normal matter. Now then, at the same time, it's expanding at the speed of light. You're basically creating more false vacuum matter than is decaying. Within that area that decays is now normal matter. It's a pocket universe. So at that point is the origin of the universe as we know it, essentially a Big Bang. Now, what proof actually exists for this? Actually, first I have a brief graphic for you guys of what that would look like at the origin point of the multiverse. That blue point right there would be the cosmic microwave background radiation. More on that later. So essentially, what actual proof exists for this? Now, with the quantum multiverse, there are two main theories that exist for why quantum physics occurs, one of which I explained, and the other is wave function collapse. So, unfortunately, both of those work for the quantum physics world that we know, and so we can't prove or disprove either one of those until we know more. However, cosmic inflation actually has a slightly larger bit of proof. The cosmic microwave background radiation. Now, picture that you have a hot mug of coffee and you're standing outside right now. I think it's, 40, 50 degrees. It's quite cold, and so eventually, first law of thermodynamics says that your coffee should get cold. It should meet the temperature of the area in which it is. Now, picture our universe. If it started as what we know of our universe today, 13.8 billion light years across, it shouldn't be even, but it is. And so basically what that points to is a moment in which it originated in one small area, and it was small enough for the first law of thermodynamics to allow it to be relatively uniform throughout. Now then, there are some areas where it's not. Take, for example, this one spot here, referred to as the cold spot. Now, this image here is of electromagnetic radiation in our known universe. And that spot right there is an anomaly. It shouldn't exist. It's actually about 4 times as much as the average deviation from its regular temperature. So what that potentially could be is a cosmic bruise on our universe. Essentially, in the early inflationary phase, in that video that I showed you guys earlier, our universe could have collided with another, which sounds really cool and is really cool, but overall wouldn't leave a whole lot more than just that. Which then means we can't technically prove it, because that video that I showed you, every other universe is expanding away from us at the speed of light. We can't view it, and it can't view us, which kind of sucks, if I'm being honest. And so, why does this actually matter? We can't observe these other universes. We can't prove that the quantum multiverse even exists. So why even bother talking about it? From a physical standpoint, you will walk away from this TED Talk completely unaffected. However, when you try and sleep tonight, perhaps not. As somebody who is in a bunch of math classes, it's very difficult to motivate myself to do work, especially considering that if there are an infinite number of universes, that means that there is one that is infinitely smarter than I will ever be. And so, now then, the multiverse isn't technically something that we can define or is even tangible. It's merely an idea, a scientific hypothesis. And so, essentially, the good news is that if this is all true, at least there are other multiverse views also contemplating its existence. Thank you.